So again, guys, this is just a review. Get used to us doing this. This is what we're going to be doing pretty much almost every day. Warm up, covering material that we have covered all semester. Okay? You know, this is from Unit 2B. This is also Unit 2B. This is Unit 1A. This is Unit 1A. This is Unit 1A. So these are all materials that you have seen, and this is just to get you prepared for that benchmark exam that you're going to be taking in a couple weeks. Okay? All right, so for here, the perimeter of a triangle is 38 inches. What does perimeter mean again? What does that mean that we are doing, Hazefa? Adding. Adding what? What are we adding, Caleb? The sides. You're adding all the sides together. That's what perimeter means. Perimeter means that we are going to be adding. You are going to add all sides. Doesn't matter if it's a triangle, if it's a square, if it's a rectangle, if it's a pentagon, if it's a hexagon. You're adding all the sides of that shape. In this case, it's a triangle, so there's only 3 sides. So we're adding those sides together, which happens to be 4x, 3x minus 8, and 2x plus the 9. We're adding those values together. So I'm going to go ahead and write that out. 4x plus 3x minus 8 plus 2x plus 19. And the whole thing is going to be equal to the perimeter, which is 38. Okay, from here, we then focus on doing things like combining our like terms. So we do have like terms as variables, right? We've got 4x, we've got a positive 3x, and we've got a positive 2x. 4x plus 3x plus 2x is going to give us what?
9.
Very good. 4x plus 3x plus the 2x is going to give us 9x. So we get 9x. Then we've got a negative 8 and a positive 19. We have a negative 8 and a positive 19. What does that come out to? Positive 11. So we have positive 11. And then the whole thing is set equal to 38. Then we can start solving, right? We simplified our expression down as much as we could. Now we can start doing the inverse operations or solving the equation. What do we do first to solve the equation, Crystal? Subtract 11. We're going to subtract 11 from both sides. It's going to give us 9x, which is now equal to 27. What is the last step that we need to do here, Caleb? Divide. So we're going to divide by 9 on both sides, and we'll get that x is going to be equal to 3. Okay, x is going to be equal to 3. All right, for problem number 2, we have 2/3 on the outside, and inside parentheses we've got 18x minus 24, and then the whole thing is set equal to negative 4. What are we supposed to do first? Whenever we see parentheses, everyone should have their hand raised to answer something like this. If we see parentheses, what are we supposed to do, Noman?
We're supposed to
Distribute. And what operation is distributive property, Chisimdi? When I say distribute, what am I actually doing? What operation am I doing? Multiplying. Good. So we're taking this 2/3 and we're going to multiply it to the 18x, and we're going to multiply it to that negative 24. I'll zoom in so it's a little easier to see. We're just taking 2/3 times 18x and 2/3 times that negative 24. 2/3 times 18x is going to come out to 12x. And then 2/3 times negative 24 comes out to negative 16. So we wind up getting 12x minus 16. And then the whole thing is still equal to negative 4. From there, we now have a two-step equation. Aliana, what are we supposed to do first? Good. We're going to add 16 on both sides. We're going to add the 16 on both sides. That way we can go ahead and cancel this part out. We're left with that 12x is now equal to 12. Amaria, what do we do now? You divide by 12 on both sides. Good. Okay, it's just the same process over and over and over again, guys, that we've been doing. We're going to divide by 12 onto both sides, and we'll get x is now equal to a positive 1. Okay? All right, now a little bit further back in history for us. Lisa is riding a roller coaster. She starts at 2 feet above the ground. The coaster rises 40 feet before it dives 48 into a tunnel. Then it climbs back up 18 feet. Where is the roller coaster located at now? So all of these terms that they're giving to us, that it's above the ground, it rises, it dives, it climbs back up. These are all integer representations. This is all an addition problem, but you have to figure out whether you're adding positive or negative values. So I know that all of these numbers are going to either be positive or negatives, and I'm going to combine them together. So let's go through the terms. Let's start with the 2 feet above ground. Sanaya, 2 feet above ground. Is that a positive or negative? Positive, right? It's above. Above the ground means that it's going to be a positive value. So we've got a 2. Then we're going to add our next value. The next value says that the coaster rises 40 feet. Rises 40 feet. Alfred, what does rise mean? Is it positive or negative?
Positive.
Positive. Rises is going to be a positive value. So we're going to add 40. Okay, then it dives 48. It dives 48. What kind of value is dive, Eli?
Negative.
Negative. So we are adding a negative value now. Dives 48 means it's going to be a negative number. Negative 48. Then it climbs back up 18 feet. Climbs back up. Brooklyn, what is that kind of value going to be? Positive. If it climbs up, means it's increasing, it's going to be a positive value. So we are going to be adding a positive 18. And then that's it. Now you just combine all those together in your calculator. 2 plus 40 plus a negative 48 plus a positive 18. What is that going to come out to? 12. Okay, so it is currently 12 feet. And since it's a positive, does that mean it's above or below the ground? Above. It's 12 feet above ground. 12 feet above the ground. All right. A bird is flying 8 feet above a 24-foot tree. You have a mouse that is 3 feet below ground. How far apart is the mouse from the bird? How far apart is the mouse going to be from the bird? Huzaifa? Sure. 35 feet. Good. Yeah, they're 35 feet apart. Okay? So remember, when we're trying to figure out how far apart something is, that's distance. And distance is always going to be an absolute value. Distance is always going to be of an absolute value, which means it's always going to have to be a positive. So if we're trying to figure out how far apart they are, guys, sometimes the easiest thing you can do is draw it out. Okay? You've got a mouse, and then the mouse is below a tree, and then there's a bird flying above the tree. Okay? There's my bird. So now I just have to break it down. From the mouse to the ground, that's 3 feet. Right? The mouse would have to climb 3 feet to get to the ground level. From the ground to the top of the tree, that's 24 feet. And from the top of the tree to where the bird is, that's 8 feet. Now, even though I know that the mouse is below ground and that's a negative, when we are trying to see how far apart they are, you've got to think of it as absolute value. So you're going to take the absolute value of negative 3, which is the mouse. You're going to take the absolute value of the height of the tree. And then you're going to take absolute value of how far away the bird is from the tree. And you combine those absolute values together. What is the absolute value of -3? +3. What's the absolute value of 24? 24. What's the absolute value of 8? 8. So when you add those together, it's going to come out to a +35. So they are 35 feet away from each other. All right, and then the last problem, number 5. We're taking -6 plus 2 and we're modeling it on the number line. So remember those number line problems? Nathan, what do we always start at? We always start at 0. You always start at 0, and from 0, where are we going to go? Are we going to go to the left or to the right? To the left. How do we know? Because the first value is a negative. And how far are we going to go? 6 spots. So starting at 0, we are going to move 6 spots to the left. We are going to move 6 left. So that's going to bring us to that -6. Okay, then what do? You move 2 to the right, right? We're going to move 2 to the right. So am I going to start at 0 and move 2 to the right? You start from -6. You start from where you left off and move 2 positions to the right. So that's 1, 2, and there's your final answer. Our answer would be at -4. Modeling it on a number line is important. You need to know how to be able to do that. Okay? Any questions? Yeah, I can leave it on here for just a minute. All right, so let's go ahead and turn our paper on over to the back side. On the back, on the back side, we are going to be talking about unit rates now. So yesterday we talked about a rate. We talked about what rates were and what ratios were. Now we're going to talk about what a unit rate is. And a unit rate is when you take a value and you simplify it. So remember we talked about how we can set rates up as fractions. We simplify it so that the denominator is always a value of 1. Okay, and some of the common ones that we've seen in basically in the real world, Christian, Hosian, head up, is things like miles per hour, your speed limit. When you are driving in a car, miles per hour, that is a unit rate. When you go grocery shopping, how much you are paying, your price per pound, that is a unit rate. It's called unit price. And in fact, savvy shoppers, people who save a lot of money, they tend to shop based off of what the unit rate is. So I can go to the store and I can buy, a small box of Cheerios or a big box of Cheerios. And I have to decide, okay, which one is going to be the better deal for me? If I know I'm going to be eating Cheerios all the time and it's not going to go bad, then I might wind up going with the bigger box if the unit price winds up being cheaper than the small box. Okay? So you'll see them sometimes off on the side where it's going to look here. I'm going to pause the video for just a second. All right. So for here, again, the idea of the unit rate is you're setting it up as a fraction, and your goal is to get that denominator to be a value of 1. Okay, so if I'm looking at this problem, it says during exercise your heart rate is 675 beats in 5 minutes, then how many beats per minute will your heart rate be? Okay, so it tells you exactly how it wants you to set it up. You need to set it up as beats per minute. So that means when you set it up as a fraction, you're going to put the number of beats on top and the number of minutes on the bottom. So the question tells you exactly how you are setting this up. You are setting it up as beats over minutes. So how many beats did my heart rate beat for? 675, right? We have 675 beats for the heart. How many minutes? 5 minutes. Okay, now the goal is to get the denominator to be a value of 1. How can I make that denominator a value of 1, Christian? By what? By dividing. What am I going to divide by? 5. But here's the thing. If I divide the bottom by 5, what do you think I need to do on the top? Divide the top by 5. Okay, whatever you do to the bottom, you must do the same thing to top because you have to keep it equivalent. That keyword equivalent, what does equivalent mean? Equal. Thank you, Chisimdi, for raising your hand too. It means equal. It means it's going to keep it the same, right? So we want to make sure that whatever we're doing is going to make it equivalent, an equivalent value. Okay? So when we do 675 divided by 5, that's going to come out to 135. And that's 135 beats per 1 minute. 135 beats per 1 minute. That's what your goal is. Okay? Huh? Yes, you do want to write the words because you're going to be getting into the point where you're going to start getting graphs and your different axes are going to have labels, and then from the graph you have to identify what a point represents, and you have to understand it represents a certain value per another value. Okay, so you want to get used to writing those unit rates with their actual units involved. Okay, problem number 2. In order to make 4 large pizzas, Paul needs 14 cups of cheese. So we want to know how much cheese does he need for 1 pizza. So when I set up my fraction, what value is going to go on top? The cheese, right? The amount of cheese, okay, which is correct. That is 14, right? It's 14 cups of cheese. And what goes on the bottom? The pizzas, right? The number of pizzas, which happens to be how many? 4. 4 pizzas. Okay, now we need to make this into a unit rate. So what are we going to do to make it into a unit rate, Caleb? Divide by what? By 4, right? Whatever the denominator is, we're going to divide by it. Now, here's the thing. Some people might pause and go, well, hold on, 14 can't be divided by 4. That's okay. When you're making a unit rate, it's okay if you get a decimal value. It's okay if you get a repeated decimal value. It is okay to do that because the idea of a unit rate is it must make the denominator a value of 1. So you always divide by whatever your denominator is. So when we do 14 divided by 4, you're going to get 3.5. So that's 3.5 cups of cheese per what? Per pizza. 3.5 cups of cheese per pizza or per 1 pizza. Go ahead and try number 3 on your own. All right, let's take a look at problem number 3. It says James wants to drive 288 miles to Rainbow Falls. It takes 6 hours to get there, so what is the average speed that he's going to be traveling at? So if I'm talking about average speed, what kind of fraction is it? Just like, we did beats over minutes and cheese over pizzas. What is the vocabulary that we would probably use in this case? Alan?
Miles on top and hours on the bottom.
Very good. Miles on the top, hours on the bottom. It's the number of miles over the number of hours, and of course speed, average speed, your miles per hour is what we're going to be looking for. So when we set this up, we've got 288 miles on the top and 6 hours on the bottom. Okay, what are we going to simplify them by? We're dividing them both by what, Amaria? 6. We're going to divide both the numerator and the denominator by 6, and when we do that, how many miles per hour is he going to be driving for? 48. Good. So it's 48 miles per hour. Okay, so those are unit rates. You also have what's called unit price, and that's when you are paying something for an item or for, a quantity of stuff. So notice I put my little dollar on top. Money always goes on top. Whenever you're talking about price, money always gets divided by the number of items or by the size of the item. Okay, that's how you find unit rate or unit price. Money always has to go on top. Okay, and now when you're talking about better deals, the cheaper the unit price is, the better the deal. So when you are comparing, you're looking for whichever one has a cheaper or smaller unit price. Okay, so if you don't understand that key word, Eli and Jesse, heads up. Eli, head up. I'm going to make you stand. Okay, the cheaper the unit price means that it's the smaller value, the smaller price. Okay, that's what keywords means for cheaper. Okay, so let's take a look at this one. For problem number 1, if you want to buy 3 different sizes of lemonade, okay, you have these options. You need to figure out which one's going to be the cheaper deal. You've got 12 ounces for 99 cents. You have 18 ounces for $1.59. Or you can do 24 ounces for $1.79. Okay, so we want to know which one's going to be the better deal for us to go with. So again, what you're going to do is you are going to break it down into a unit price. We're going to take the price, the money, and we're going to divide it by the item or the size of the item. So let's talk about this first one, 12 ounces for $1.99. We are going to take the money, $1.99, or I'm sorry, not dollar, sorry, 99 cents, not $1.99. 99 cents, and we are going to divide it by 12 because it's 12 ounces. Now, when we do that, here's the thing. You're going to get 0.0825. This is supposed to be money, though. Is that money? No. Last I checked, I want you to figure out how are you going to give me 0.0825 cents. You're not going to do that, right? Because what's the smallest amount of coin you can have? A penny. And a penny stops at that 8. That 8 is where the penny spot is. That 8 is where the penny spot is. So your money is located right here. That's 0.08. Whatever is behind it is going to tell you how to round. Whatever's behind it is going to tell you how to round. So this 2 that's behind it is going to tell me I'm either going to keep my money at 8 cents or I'm going to round it up to the next penny, which is 9 cents. So am I going to keep or am I going to round up? Keep. We're going to keep. Okay, this is going to be just 8 cents. Okay, now we're going to do the same thing for the next one. Let's talk about 18 ounces for $1.59. 18 ounces for $1.59. So I'm going to take $1.59 and I'm going to divide it by 18. $1.59 divided by 18. And again, it comes out to a long decimal, 0.088. And then the 3 keeps repeating, doesn't it? So again, my money is only this 0.08. That's where my money is. The number directly behind that is going to tell me either to keep it at 8 cents or round it to 9 cents. Am I going to keep it or round it? Round it, right? Do you guys remember the saying? If it's 4 or below, you just let it go. You leave it alone. If it's 5 or above, you give it a shove. You shove it up to the next value. Okay? 4 or below, you let it go. 5 or above, you give it a shove. This is an 8. That's above 5. So that means we need to shove this up to the next value. The next value is 9 cents. So this is going to be rounded to about 0.09. or 9 cents. All right, let's take a look at the next one. We have, for 24 ounces, we can do $1.79. So I'm going to take $1.79, and I'm going to divide it by what? 24. We're going to take $1.79 and divide it by 24. Okay, when we do that, it comes out to 0.07458. The 3 keeps repeating. It goes on forever. So again, my money is only going to be at this part right here, 0.07. And now I need to look at that 4. Am I going to keep at 0.07, or am I going to round to 0.8? Keep, right? 4 or below, you just let it go. You leave it alone. So this is going to be roughly 7 cents. So based off of that, which one of these prices is going to be the better deal? The third one. Good. So this one right here, $1.79, even though $1.79 is the most expensive, it's the cheapest deal. This is the better deal. So again, you always take money and divide it by the item. You always take the money and divide it by the item. I want you to do problem number 2 on your own. Do problem number 2 on your own. All right, let's talk about this first one, the $3.60 for 150 liters. We should be dividing $3.60 by 150. And what is that going to give us?
0.02.
Okay, 0.024. But he rounded already. He went ahead and rounded it and was like, okay, I know I need to round to the nearest penny. So when he rounded to the nearest penny, he saw this is where our money is. This is the value that's behind our penny. It's a 4, so we're going to just keep it at 2 cents. So it's 0.02 or 2 cents, right? Okay. What about the next one? What's the next set that we're going to go ahead and divide? What's the next set?
$3.51 divided by 130.
Good. $3.51 divided by 130. Okay, when we divide, what do we get? 0.027, yeah, 0.027, and then Huzaifa, you rounded it to the next value, right? He said it's 3 cents, because even though it's 0.02, the value behind it is a 7, right? And Alfred, remember we said 5 or above, we give it shove, right? We round it up. We round it up to the next value. So this is going to be 3 cents. So far, which one's cheaper? The first one. So far, the first one's cheaper, right? Okay, let's take a look at the last one. Our last one is $7 for 200 liters. So we're going to do 7 divided by 200. 7 divided by 200, that's going to come out to 0.035. What's that going to estimate to? 0.04, right? We're going to estimate to 0.04 because, again, even though that 0.03 is the money, it has a 5 at the end. That 5 tells us to round it up. So it's 4 cents. So the cheapest deal happens to be the one for 150 liters. 150 liters happens to be the better deal. Right? There's our cheaper item. Okay, so what you guys are going to be doing, you might have a little bit of time to start today. Actually, you might not. Let me go ahead and stop this real quick.